two inequalities here, one linear, one quadratic. Our idea is to look at the quadratic, but just to be clear what we're up to, we're going to just do a linear inequality very quickly and then contrast the two. So our linear inequality, operations very much like solving an equation, subtract x from both sides, add 8 to both sides, and our answer 21 over 2 or 10.5. So x greater than 10.5. Now let's contrast that to our quadratic inequality. Operations, once again, very much like the equations, and for inequalities we look for these critical values where it's going to be equal to 0. So critical values, looking for equal to 0. I think I can factorise this one. 2 and 7 will give me the 14. Minus 7x plus 2x would give me the 5x. And so what I'm looking at here, and I'm going to put this on a number line so that I can, let me sketch myself a number line. And the zeros, what the critical values where this will 0 will be at when x is minus 2, this bracket will 0, and at x equals 7, this will 0, and that will give us 3 regions to consider. So it divides our number line into 3 regions, and we have to ask ourselves in which of these regions is it greater than 0. Now we could always simply take a number, put it in and see if it is greater than or less than 0. And another way of doing this would be to ask ourselves what the graph looks like. Now positive x squared, what will happen here if we drew the graph? We would see this, and it would be fairly clear, I hope, that at this point and at this point the graph is greater than 0, and we have our answers. So thinking about the graph, thinking about these critical 0 points to split our line, we can say that our answer would be x less than minus 2 or x greater than 7. And those are the areas which solve our inequality.